All right, boys and girls, welcome to the drive-thru. We are a go. Took a little while for Carson and I to get set up, but we're here to do a little Chapter 3 test, preview, review for you. Okay? Most important thing you can do to get ready for the test is know what to expect. So I encourage you to pause the video and read through these words. Okay? Carson, what's the difference between solving and simplifying?
Solving is where you find for the exact answer.
That's right. Solving, you find an answer.
Simplifying is just making it at the smallest term.
Simplifying, you make it look differently. Exactly. Okay? All right. So this review should give you a good idea of what you're going to have to know and what you're going to have to be able to do on the test. So here we're going to start out by solving for x. Okay? In this equation, we have to distribute first. So you get 27x. Whoops. 27x minus 90 is 2x plus 5. Now we want to get all the like terms on the same side. So I'm going to subtract 2x. That gives us 25x minus 90 is 5. I'm going to add 90 to both sides. I get 25x is 95. Can you do 25 or 95 divided by 25 for me, Carson? 3.8. Okay. In this one, I don't really like working with fractions, so I'm going to multiply both sides by 7 to start, Carson. On this side, the 7 divided by 7 is 1, and those have canceled out. So you just have 3 minus 2x. And on this side, you have 7x plus 84. Busonic. All right, now we're in a similar spot to the last one. Let's add 2x to both sides. So you get 3 is this of 2x, sorry, ViewSonic, is 9x plus 84. Subtract 84 from both sides. You get negative 81 is 9x. Divide each side by 9. And you get x is equal to negative 9. You should put those answers back into the original equations and make sure that they work. Okay? Come on now. Come on now. Come on now. Come on, you can do it. There we go. All right, now, notice in these directions it says simplify. There is no equal sign. So, when we're multiplying things with the same base, you add the exponents. 3 divided by 9 is the same thing as 1/3. My buddy Carson just said, just take this one step at a time.
So you look at the 4.
Yeah.
And that's basically a 1, so you just 4 minus 1.
X to the 4th over x to the 1st is? So we have an x to the 3rd on top.
And then you do negative 2 minus 3.
And what's negative 2 minus 3?
Negative 5.
So we can either write y to the negative 5th on top, but that's not really preferred in math. So then what we do because of the rule is write y to the positive 5th. If I could ever figure out how to get this to erase one more time. We're going to write y to the positive 5th on the bottom. If you put y to the negative 5th on top, I don't even think I'd mark it wrong here. Okay? This is also a z to the 1st.
So you would subtract 2 minus 1 and you get z to the 2nd.
And that is your final answer. It is simplified as much as we can simplify it. Okay? You're going to see something like this on the test. It's going to be really intimidating, and anything to the 0 power, Carson, is 1. Okay, so that simplifies to 1. Why is x to the 0 equal 1, Carson?
Because you're not multiplying by anything, and it's just by itself.
Well, it's x to the 0 is 1 so that our rules can work, okay? So what is x to the 6th over x to the 6th? Well, what is anything divided by itself?
1. Or whatever.
It equals 1. However, we learned a different rule. X to the 6th divided by x to the 6th. When we have the same base, what do we do with our exponents?
We subtract.
We subtract them.
And x to the 0 is the same thing.
And that is x to the 0. So, by transitive, x to the 6th over x to the 6th equals 1, and it equals x to the 0. Therefore, x to the 0 must equal 1. That's the best explanation I can give. Okay? Alright. Mrs. Wood is super stressed from all the work she has to do in the Citivation Lab, and she decided to run off some steam. She has currently run 4 miles and will continue to run at a rate of 5 miles per hour for the coming hours. The first thing it says is make a T-chart to represent some different hours or different distances that Taylor has run for various hours. Well, currently, how far has she run? So after 0 more hours, she has run 4 miles. Okay? After 1 hour, she will have run 9. After 2 hours, I don't think so. 14, right? 9 plus 5. Okay, it's Monday. After 3 hours, 19. All right, that's enough. What is the slope in this situation, Carson? It is 5. Look for the per. We are adding 5 every hour. She's going 5 miles per hour. That's her rate. Okay, it is arithmetic. Very good. It is arithmetic. It is linear. Very good. What is the y-intercept?
4.
It is 4. It's where she begins. Okay. So let's do the explicit formula first.
Y equals mx
y equals mx
plus b.
plus b. So for this one, it's going to be y equals. What's the slope? 5 per hour plus 4, which is where she was when we started counting. Okay? Now, let's do the recursive.
F of n.
To find any number,
F.
we take the previous number and do what to it, Carson?
N minus 1.
Oh, thank you. Yeah, you take f of n minus 1. What do we do to it?
We add.
What do we add?
We add the slope.
So what do we add in this one?
5.
That's right. Okay? We also need to tell the computer somewhere to start, so we'll just say that f of 1 is 9. You could have picked any data point for that. All right. Which one of these is linear, Carson? The first one is linear. What is the y-intercept?
Negative 5.
So we're going to start down 5. And then our slope is 4. So if I go over 1, I go up 4. Over 1, up 4. I'll get my straight edge. And that's going to be a line. Let's graph that in my graphing calculator real quick. All right, so if I put in y equals 4x minus 4, and I graph it, you'll see it looks very similar. Okay? Now, on the next one, let's put it in our graphing calculator and then put it in our table. So y equals 0.5 parentheses 2 to the x power, whoops, delete, 2 to the x power, there we go, okay, graph it. Alright, it's exponential. Let me just go to the table. So second graph gets me to the table. At 0, I have 1/2. I just wish it would work, but we know that it won't because it's fusodic. At 1, we have 1. At 2, we have 2. It is geometric. Very good. Let's get our calculator back up if we can. Come on, just work. Scroll down. Three is 4 and 4 is 8. So over 3 up 4, over 4 up 8, and now I start to see that it's exponential. Okay? Determine whether these are functions. For a function, I got to draw the vertical line test. Do any of those lines hit more than 1 point if they were straight lines? Nope. What about these? This one fails the vertical line test, so this is not a function. And this one is a function. F-U-N-C, function. And finally, oh, we got a couple more. What is the domain? Do you know what the domain is, Carson? All of the possible x values. And the range? All of the possible y values. Okay. What's the equation of this graph? Well, it looks like the y-intercept, excuse me, the y-intercept is 2. It does look like it's 3, but it looks like it is -3. So this is going to be y equals -3x plus 2. Are you ready for this thing, Carson? You're going to start this week with an A+? Boom!